Welcome to Study Loop.
So if we simplify the circuit diagram, which is here, uh, we get something like this, where the 12 ohms and 22 ohms resistor are in series, are in parallel, and then 4.5 ohms resistor is in series with these two guys, and then this whole setup is in parallel connection with 14 ohms. And let's actually call this setup R12, so that it's easier to calculate. Now, the first job for us is to find out this R12 value. So it's going to be R12, which is equal to 1 over 12 ohms plus 1 over 22 ohms, reciprocal of that. And that gives us 7.765 ohms. Now, since this guy is in series connection with 4.5, so the total, and then let's call this guy R3. So the total um, equivalent resistance will be R123, which is 4.5 plus 7.765 ohms, which is equal to 12.265 ohms. Okay, let's actually make some space here. Right, so yeah, so now we know this, and from there we know that 14 ohms is in parallel connection with this whole setup, so that's going to be R EQ, which is parallel, so that's going to be 1 over 1265 ohms, so that's this guy, plus 1 over 14 ohms, reciprocal of that, and that gives us, all right, and that gives us 6.538 ohms. Let me actually represent it properly so that we can understand. So now this whole setup, we call this R1, 2, 3. Right, so that's the equivalent resistance of the whole circuit. Now for part B, we need to find the current that's going through this resistor, 14 ohm. So what we can do is we can apply Kirchhoff's loop rule on this loop, and if we do so, we see it's going to be psi minus I14 times R14. So I14 is basically the current that's passing through 14 ohm resistor. So if we solve for I14, we get something like this, and here our EMF voltage or psi is given, so that's how we get our current. So now we know that 0.4286 amps current is going through this part. So we need to figure out what amount of current is going through. Um, we need to figure out what amount of current is going through R12 and R22. R12 to be precise. So what we do here is, again, we're using Kirchhoff's law loop rule for the outer loop, and by outer loop we mean that we take this whole thing and we're considering these two resistor as one. So that means instead of writing these two separately, we're writing R12. So that means the current, so that means this guy and this whole thing is in series connection, so the current flowing through the setup will be same. So that's what we did here. So psi is positive because so we're taking direction which is anti clockwise. So then yeah, the current passing through the equivalent resistance, then the same current is passing through 4.5 ohm resistor as well, and this total thing gives us 0. So from there we get our I12 current, the current that is passing through this system. And if we solve for it, so we know all the values, we got those here, and 4.5 is known. So if we plug in the numbers, we get our current as 0.4892 amps. And from there we can solve for I12, and that's gonna be okay. So before we solve for I12, we should know that now this I1-2 current that is passing through this guy is a sum of I that's current passing through 12 ohm resistor and the current that is passing through this 22 ohm resistor, because they're in parallel connection, so we add the current. So that's what we did here. So, and this is the hint for getting I12, or the current that is passing through 12 ohm resistor. Now what we are doing here is, first we're trying to find out, we're trying to replace I22. So that's why we're writing I22 in terms of I1-2 minus I12. And the reason we're doing this is the following. So we know that the voltage across these two ends are equal because they're in parallel connection. So the voltage for 12 ohms will be equal to the voltage for 22 ohms, which is represented here. And since this is the case, we can use Ohm's law, and Ohm's law tells us I times R equals V. So that's what we did. So this is the current for 12 ohm resistor, and this is the current for 22 ohm resistor. So that's that. And from there we can substitute I22 in this expression, and we get something like this. So once we substitute this expression in this equation and then do some um, mathematical derivation, we get I12 as I1-2 times R22 divided by R12 plus R22. And we know all the values, we plug those numbers, and that way we get the current that's passing through 12 ohm resistor. Okay, so let's see, that was part C. Yeah, so for the final part, we know that through 4.5 resistor, I1-2 amount of current is passing, because this whole setup is in series connection with that. So that means the same amount of current will be passing through both. So the current that's passing through 4.5 ohm resistor is equal to I1-2. And we know that power is basically I squared times R. So we can get I12 from here, and R 4.5 is 4.5. So we plug in the values, we get 4.4892 amps squared times 4.5 ohms, and that gives us the power is 1.077 watt. Thank you.